So in this part of inventory control, we will discuss about the inventory model. So inventory model with shortage. So we are having, we are providing, we are allowing shortage. So we'll see a few terms, few new terms over here. So we have simple plot, and one plot is we have we have quantity and time. So first we are discussing the plot, and that plot is quantity with time. So initially we have some quantity and we are consuming this quantity. So this quantity will become 0, and at this point there is a demand, and that demand is a quantity S star, but we don't have any supply. So because we don't have any supply, so what we have, we have a shortage of quantity, and that shortage. So if we have shortage, so we can have a maximum, we can have a minimum shortage, so that we can have a minimum losses. So shortage will give you some losses, and that losses will be in terms of, because you have a shortage. So what will happen, the customer who is arriving at your store, at your plot, at your plant, so they will return, they will not have sufficient quantity. So there is a demand, but you don't have any quantity, so the customer will get a return. So because if you able to solve, if you able to sell some quantity with that customer, you will have some profit, but because that customer getting return, so there may be chance that that customer will not come in the future, so it will also give loss in the another terms. You have also since you have you don't have quantity, sufficient quantity, you don't have quantity to supply the demand, but the employees associated with you or your company, they are working, so you have to pay the salaries for that. For those employees, you have to pay the rent for that you have, if you have hired some office, if you are consuming some electricity bill, some telephonic bill, so you have to pay for that, and those costs will come under the category of shortage, because you don't have any supply and you have demand, but you are not able to sell the product. So that's why you have some shortage, and that shortage will give you as a loss, as a penalty. So that cost we will target that cost should be minimized. Whatever the possible way, we can have a minimum shortage, and we can have minimum shortage cost. So we'll discuss. So here this is a plot, and this plot is in between the quantity and this time. So we'll see how this quantity and time is altering or changing the shortage inventory model. So we have some demand Q star, or you can say EOQ, economic order quantity. So if you have this demand, when you supply this quantity, when you have this quantity, this quantity will consume, and at this time we don't have any quantity in hand, but there is a demand, and that demand is S star. You don't have any quantity, but there is a demand, and that demand will go as shortage. So initially you have Q star quantity, and finally you have shortage, so that is S star. So we'll see again this quantity you are getting, and you are consuming this quantity, and at the time here we have 0 quantity, but there is a demand, and that demand will go as a shortage. So we have this will go repeated in periodic. So each time you are having a lot size, and you will consume that lot size, and after some time you have some for some period you have shortage of quantity, and that time period is T2. So here we have some variables we have used, Q star, and that Q star is economic order quantity, EOQ, and S star is the optimum shortage. So there is a shortage, so what we will target is, so we can reduce the shortage, and we will try to minimize the shortage, and that quantity will be optimum shortage. We have also shortage cost, and that cost is CS, because if you have shortage, so that will give you some penalty, and that penalty is shortage cost, and that cost is CS, and that is per unit per year. We have two times, one is consumption time, or we have also second time is that is shortage time. Here we have some cost, and that cost is purchase cost, that is the fixed cost, and that cost is purchase cost, and that is A into C. We have also another cost, and that is similar to we have order cost, and that ordering cost or order cost is A by Q into S, like earlier model, first model we have. We have also inventory carrying cost, and that is maximum inventory by 2 into CI. So maximum inventory, how much we have? Q star minus S star, because so maximum inventory we have Q star minus S star, minimum inventory is 0, and finally we have Q star minus S star by 2 will be the average inventory. So we have inventory carrying cost is Q star minus S star by 2 and into CI. So this CI is inventory carrying cost per unit, and number of quantities we are getting from I max by 2, and that is Q star minus X star by 2. So this value will give you the maximum inventory we have. So again we will find some shortage cost we have, and the shortage cost, initially we have zero shortage at this particular point, and at this point of time we have maximum shortage, and that shortage is S star. So here we have no shortage, so this is 0 plus S star by 2. So this will give you the average shortage, and if you multiply this average shortage with shortage cost, you will have a shortage cost, total shortage cost. So we have shortage cost S star by 2 into CS, and we have also another cost, that is total variable cost. So total variable cost, we have three terms in the total variable cost. One is the ordering cost, inventory carrying cost, and third one is the shortage cost. In the earlier model we have only two costs, but one extra cost come here over here is the shortage cost, and that cost is S star by 2 into CS, average quantity shortage into shortage cost per unit. This is average quantity carried or holding and into holding cost per unit. So this will give you the total variable cost. And if we talk about the total annual cost, so this fixed cost will come, and this will give you the total annual cost. So this is the fixed cost, or you can say purchase cost, ordering cost, carrying cost, inventory carrying cost, and this is your shortage cost. So we can find the optimum shortage also. So optimum shortage, or you can say if we have shortage, then what will be the economic production what will have the economic order quantity. So economic order quantity Q star for including the shortage will be the 2S into CI, where is a annual demand, S is the cost per unit per order, CI we have inventory carrying cost, and CS we have shortage cost. We can also have optimum shortage, and that shortage can be calculated by this particular formula, where all the variables have same meaning what we have in the EOQ, economic order quantity. If you have ordering quantity, if you have at EOQ, what will happen at if ordering cost, inventory carrying cost, and shortage cost are equal, then total variable cost will be 3 times of any of 1, because all these three are equal. So at economic order quantity, if ordering cost, inventory carrying cost, and shortage cost are equal, then total variable cost will be 3 times of any of 1. So any of the following will give you, if you all multiply with 3, this will give you the total variable cost. Now we will discuss one problem which is based on the shortage model. So in the inventory model with the shortage, we will discuss this particular problem. So in this particular problem, there is demand of an item, and that demand is 25 units per month. So if you multiply by 12, then you have demand, and that is annual demand. So this will give you the annual demand A. So this will give you the 300 as annual demand. The fixed cost is rupees 30. So each time a production run is made, so this is the each time a production run is made. So this is nothing but the each time production run is made is the, this is the setup cost, and that is S. The production cost is rupees 2. This is unit cost per item. So this is the C, production cost C, and inventory carrying cost is 50 paisa. So inventory carrying cost CI is 50 paisa per unit per month. So we'll convert this CI into per year. So we'll multiply by 12. So this will give you 6 rupees, because 50 paisa multiplied by 6. So if you convert into rupees, so you have to divide by 100. So this will give you in the rupees, into 12. So this will give you 6 rupees. So 6 rupees is the inventory carrying cost. So the parameters, the values given will mark over here. So the parameters given is annual demand, that is 300 units per year. We have setup cost, or you can say production run. So each time we are running the production unit, so we have to pay an extra cost, and that is rupees 30. Unit cost is we have rupees 2. Inventory carrying cost we have half rupees per unit per month. So we have 6 rupees per year. And it is also mentioned that shortage cost is rupees 3 per unit per month. So we have shortage cost as 36 rupees per unit per year. So we have to determine how often to run a production and of what size. So we have to find number of production runs, means A by EOQ, and of what size. So we will find number of production runs, and we will find the size. So we can find production runs. So first we will find the economic order quantity. So that economic order quantity will be, we have mentioned this formula in, so 2S by CI into CI into. So we can find economic order quantity by this particular relation, 2S by CI into CI plus CS by CI. So we have A as 300 units, S we have 30. So we will place these values and we will get the economic order quantity, and that quantity is 59.16 units. So if you solve this particular expression values, unit cost we have 6 rupees as a inventory carrying cost, and shortage cost rupees 36. So rupees 30. So economic order quantity we have 59.16. Next we will find the number of production runs by A by Q, EOQ, and A we have 300, annual demand we have 300 quantity, because we have 25 quantity per month requirement. So number of production runs will be around 5. So it will be around 5, because it is around 60. So 300 by 60 will give you around 5. So number of production run is 5. Now we will find the optimum shortage. So optimum shortage we have 2S by CI, and we will put the values of these variables. We will find the optimum shortage quantity is 8.45. This is the optimum shortage quantity. Next we will find the maximum inventory, that is Imax, and Imax will be equals to Q star minus S star. Q star we have the optimum quantity is 59.16, and S star is this 8.45. This will give you 50.7. So this is the maximum inventory we have. So maximum inventory we have is 50.7, and we have economic order quantity is 59.16. Number of production runs is 5. So these are the values we have to find. So we have obtained these values in the shortage model. So we have discussed the shortage model, and we can find the value of maximum inventory we are going to store, and number of production runs we have to maintain. We have to go for finding the optimal order quantity, EOQ, economic order quantity. So with this we have discussed the shortage model. Next model we will discuss about the inventory model, and that will come with the buffer stock, or we can say safety stock.